Greetings folks and welcome to the Electromaker podcast. This is your midweek roundup of all things Maker and Embedded and Lovely, and what a interesting show we have this week. So we are at Embedded World next week, and I do mention that at the start of the show, and I'm mentioning it right at the start here too. If there is anything that you would like us to see cover at Embedded World here in Nuremberg, do let me know. We will be on the floor and we have a lot of nice meetings already lined up, but of course there are a few other things. I personally am wondering whether Arduino will have their new board, which is a collaboration with Silicon Labs there, which is their Matter ready board, and I'm sure there'll be a few other surprises along the way too. But if you notice anyone that will be at the conference that you would specifically like us to go and speak to, do let me know. As always, the Discord server is a good way to get in touch, or my email, which is ian@electromaker.io. Although I did notice that I'd missed one email from one of you for quite a while, and I apologize for that. One of the problems with having a public-facing email is that I get approximately 1,000 spam messages per day, which the spam filter seems to be able to do nothing about. But no, what makes this show the most interesting for me is that, as well as a really fascinating feature from Robin about AI SBCs, which single-board computers are good for machine learning, which is still a wild concept, by the way, to me. Machine learning is something that used to be done on mainframes a very short time ago. The real meat of what got me so excited about this show is that there have been two real breakthroughs in the last little while, and both of them were not done by large companies. They were done by individuals just with a passion to do something. One of them is in 3D printing. A YouTuber named Greenboy3D has spent the last 2 years perfecting an affordable home system for retrofitting any 3D printer to work with pellets rather than spools of plastic, which makes it much cheaper for them to print, and also makes it much more advantageous for those of us who want to make their 3D printing as eco-friendly as possible. The other thing is a wonderful project from Charles Law, who I have been a big fan of for some time. He is a creative coder and a YouTuber, and he has turned my understanding of LoRa upside down by not only making a LoRa stack from the ground up, or at very least sending packets that have been handmade, but doing it without the need for an onboard aerial, by simply generating high frequencies from one of the GPIO pins of an MCU and using some very clever digital synthesis to actually send LoRa over a surprisingly long distance. So we've got all of that stuff to get through in the show, but once again, this is a show with no sponsors, and if you would like to support us, head to electromaker.io/shop and you can find everything that you would need there. And once again, Embedded World is coming up and we will be covering that next week. Also, Hardware Pioneers is getting closer and closer, which is at the end of which is next month, but again we'll be there covering that too, so looking ahead to that if you'd like us to speak to anyone particular there or come and say hello. Robin and Rich will be in London for that event. Me and Rich will be in Nuremberg next week, and if you are at Embedded World, do drop me a message on the Discord or something, and maybe we can meet up and say hello. Anyway, that's a rather long introduction. As always, let's get on with the podcast. Now, just quickly before we begin, I'm in South Germany to see family, but also because next week is Embedded World in Nuremberg, or Nuremberg in the English way of saying it, and it's a fantastic conference. Pretty much everyone who's part of the Embedded World goes to Embedded World, strangely enough, and we have a few quite interesting interviews lined up, but if there are anyone that you would specifically like to hear from, do let us know. On the Embedded World website, which I will link in the description of this video, you can find a full rundown of all of the exhibitors that are there. There is a version that works in the browser, which is an interactive version. You can also download the PDF version of the manual that we all get when we get there. The manual? The floor plan. And if there's any names there that you are excited about hearing something for, if there's anyone that you think might have something that's worth seeing, I personally wonder whether Arduino might finally unveil the actual version of that Silicon Labs Matter board they've been talking about for a while. Please let us know in the comments or in the Discord server, because we'd love to hear from you what you'd like to see there. We have some pretty tasty things lined up already, though, which are going to be quite nice too. But yes, anyway, I wanted to get that right out at the start of the show. Link to the Embedded World website in the description of the video, and you'll be hearing a lot of cool stuff from that next week. Whether I'll be able to put out a show as well while I'm there, we'll just have to wait and see, but my time is usually quite crushed during conference season. But worry not, I'll be interviewing a lot of interesting folks. Anyway, on with the rest of the show. We're going to begin this week's show with LoRa, which is an incredible project by Charles Law, also known as CN Law on YouTube. And he is one of my favorite YouTube content creators, but also just one of my favorite creative coders. He is someone that is obsessed with breaking things down to their very minimum so he can understand them, and then rebuilding them, usually in raw C code on very underpowered microcontrollers. And basically, if you tell him something isn't possible, he will bang his head against it until it is. And he looked into LoRa and the LoRaWAN protocol and wondered, just idly, well, do you have to use a radio for that? If all you're doing is producing high frequencies and that are sent in a certain way, can you do that another way? And long story short, he has done it in a way that blows expectations out of the water. It's a very difficult thing for me to explain briefly. He has a 37-minute video of it on his YouTube channel, which I absolutely recommend you go and watch. It will be linked in the description. But here's my best attempt at explaining exactly how LoRa, Charles N. Law's LoRa library, works without the need of a radio on board or even an aerial. It is going to be incredibly difficult for me to sum up in a 2-minute Electromaker segment what Charles covers in 37 minutes on his YouTube channel, and this 37-minute video has no filler in it. This is fascinating from start to finish. Charles has a wonderful way of structuring his videos that make him very easy to understand given the complexity of the concept he is talking about. But if I was to try and give an elevator pitch for what Charles has done here, it is that he has taken the concept that any signal that is not a sine wave has higher harmonics with it. If you've ever looked at the sound a synthesizer makes through a spectral analyzer, for example, you will find that if you play quite a low note, and that note is a square wave or a sawtooth wave, there are harmonics that run all the way up the spectrum, technically towards infinity, but it doesn't quite work like that. And in fact, it is that very harmonic range that makes digital synthesis somewhat difficult for beginners, because aliasing is a problem that you will run into when those signals then reflect around a higher frequency and then create lower frequency tones that you do not want. And it is in fact something similar to this that allows Charles to not only create LoRa signals using basic microcontrollers, but without even the need of a radio on those microcontrollers. And in this video he shows it working with an ESP8266, an ESP32, and the CH32V003, of which he is very, very fond, and in fact has written the best library for working with that microcontroller, in my opinion at least. A very, in his style, very simple, bare bones, do everything yourself library, which is a little difficult to get your head around at first, but once you have, makes it very easy and very quick to iterate over things using that microcontroller. So this video, which is also just a fantastic introduction to LoRa and the idea of the harmonic series and how it reflects, how it works with different signals, really leans into this idea of if you can generate higher harmonics using a lower tone, and you can generate even more harmonics by mixing a lower tone with a higher tone, because the higher harmonics of the lower tone will reflect around the higher tone. As to why, that is very far off in the field of physics, and I am standing at the edge of the field in the tractor. I'm not going in there. But it does happen, and it's something, again, you will run into if you do digital synthesis, which is my only window into this world. I know a little bit of what's going on here because of trying to make software synthesizers in code. Anyway, if you pair the fact that you can create those higher harmonics with the fact that electrical interference happens every time you turn a GPIO pin on or off, you end up in a position where, theoretically, you can turn a GPIO pin on and off at just the right rate to generate a kind of signal that could be picked up by a LoRa receiver, maybe a few feet away. At least that is what Charles initially thought. As this video goes on to show, this ends up working far better than anyone could have ever expected, and yeah, he managed to generate LoRa packets that would be received and decoded and then would be put onto, say, the Things network or Helium as valid data using a GPIO pin being turned on and off very fast with a bit of wire as an aerial, and at one point without even using an aerial whatsoever. It is a magnificent achievement, and it is a testament to the kind of thing that Charles is into, which is taking something that seems impossible and saying, nope, I'm going to make it possible by really bashing my head against it until I understand it. And Charles is just one of my, as I think I said in the introduction, just one of my favorite code creators. He says, is this possible? Maybe it theoretically could be, and we'll work at it and come at it from different angles until it is. As I mentioned just a moment ago, there's 37 minutes worth of exposition about this project, and that shot past. I did not realize the video was that long when I clicked on it and it finished, and I looked back at the timing and thought that did not feel like that long. If you are new to CN Law's channel or Charles Law in general, please do check it out. Now, one quick disclaimer, and Charles mentions this in his video as well, this is highly experimental. This isn't something that would pass FCC regulation. This is something that could get you in trouble in your local area for doing, because this is an unregulated radio device. But it is fascinating. It is definitely really interesting to fiddle with. And I suppose one could argue that anyone who's messing with a microcontroller is creating these higher frequency sounds for exactly the reason he goes into in the video. A square wave has harmonics that theoretically go up towards infinity, although most MCUs actually drop off way before that. But yes, I did just want to throw that disclaimer in there just in case. This is a fascinating concept, but it is a proof of concept and nothing more. As always, I will leave a link to Charles's video in the description, and you can also find a link under his video to his GitHub page, the wonderfully titled LoRa repository, with all of the code you need in order to replicate this yourself. I should point out that this is, I only talked about a very small segment of the video. He took another approach to generating the correct harmonics for LoRa as well, using a PLL timer on the ESP32S2, which is documented somewhere in here, I just haven't seen it yet. Some wonderful visualizations of how LoRa actually works, with the preamble upticks here and then the actual message itself too, and some of the problems and issues with actually generating legible LoRa packets, and a whole bunch of other stuff. As I mentioned much earlier in the video, 37 minutes for this video is not overkill. It is brief given the density of the subject. I am a massive fan of Charles. I support him on Patreon, and I love the fact that there are people out there just hacking away and experimenting with everything they can, breaking it down to its bare bones and putting it together in wonderful ways like this. And if this is the first time you're hearing of Charles, you have over 10 years of wonderful videos, all looking at a variety of different stuff, usually sticking around the idea of, raw C code and embedded stuff, but a whole variety of things, including how making Android apps in pure C without having to bother with the Android developer kit and all that kind of stuff, through to creating things in VR, creating shaders for open VR headsets and things like that. Anyway, I hope you enjoyed this video as much as I did. Just a quick reminder that Electromaker makes all of its money from the Electromaker Shop. At electromaker.io/shop is where you will find pretty much anything that you would want from anybody. We have everything in stock, including things that until recently were unobtainium. Like, for example, we have a good stock of Raspberry Pi 5s currently, and anything else that you might want to get. Whether you're looking for a gift for the very first time hobby hacker as a birthday present or something like that, or you're looking for something very specific, it's worth having a look in the shop. And in fact, if you get in touch with our sales reps, if you have a very specific request, they may well be able to help you as well. We have a very good Trustpilot score, and we can ship stuff to anywhere in the world. But yes, I thought if I was going to do an advert, why not pick a nice location with which to do it in? But yeah, thank you very much for your continued support. If you haven't got the money to buy things right now, that's absolutely fine. Liking this video, subscribing on YouTube, turning on notifications, all the usual YouTuber muck gubbins absolutely helps us too. And finally, our Discord server has slowly been rising in members for a very long time. We have a few active members who chat about things all the time. If you're working on something, or just have an opinion about something, or just looking for a nice place to hang out and chat to other like-minded people, there is a link to our Discord server in the description of this video, and we'd love to have you there. The conversations when they do start there are always fascinating, and I always make an effort to join in when I can. We're going to move on now to a real breakthrough in 3D printing, which is a project put together by Greenboy 3D. He spent the last 2 years researching how to take the concept of pellet printing, which is using plastic pellets rather than spooled plastic to print, and come up with an incredible project which is almost finished. And this is a way of retrofitting any 3D printer to work with just a few custom metal parts and 3D printed parts, and turn it into a fully fledged pellet printer that will print not only with plastic, but with sugar or chocolate or anything else that is pelletized and that will melt within the right temperature range. So what makes Greenboy 3D's pellet extruder such a breakthrough? Because it's not a technological breakthrough. Pellet extruders have existed for quite some time and are used commercially, but they are very, very expensive. He mentions in the video it's going to take you anywhere from $1,000 to $7,000 to get one. I found a local quote for an industrial pellet extruding machine which was 13,000 euros, which is a little bit more than I would want to spend on a home 3D printing setup. But pellet extruding is something that is very desirable because pellets are much cheaper to print with than down your usual PLA string, as you want, if you want to call it that, your spools. Because the cost of getting pelletized plastic is much cheaper. And as he points out in the video, the cost of a print is a quarter of the cost of a spool print. There is also the environmental side to it. And of course, the environmental impact of 3D printing is hotly debated. There is no denying that the industrial waste of plastic is far greater than any personal waste or home waste of plastic, hobby waste, whatever you want to call it. I prefer to think of these things from a personal perspective. I don't really want to compare myself to others when it comes to plastic waste. I know how little plastic has been recycled since the dawn of humans making plastic. If you want to have nightmares, look that up. So the idea of me being able to recycle my own failed prints or just used recycled plastic in the first place is something that personally pleases me. However, Geekboy3D doesn't just talk about the wider implications of a home pellet extruder. He also talks about the personal problems he had coming up with his design. And his design is really simple and really wonderful. Essentially, it uses a spool loader, as you would usually expect. And that spool loader will fit into a regular motor, the kind that you would find in a regular stepper motor that you would find in any 3D printer. He made a point of using regular parts, regular fans, nothing weird, nothing that wouldn't work with your already existing firmware and hardware. And the housing itself is 3D printed, which might seem a little bit weird at first, given it's going to be so close to a hot end. In fact, this is exactly the point in the video he is talking about it. And yet he goes into some detail as to why this is not an issue and some of the options that you could use if you wanted to print at higher temperatures than 300 degrees Celsius. And the other side of it as well is just that the design is designed to accommodate any base plate that you want. He's come up with a bunch of designs that fit base plates for most of the 3D printers, meaning that you can attach it directly to the print head of the printer without having to modify any designs. And if you want to, he shows how simple it is to do that as well. But yes, Greenboy goes on to show that the quality of the prints is very, very high with pellets, and yet this is something that has a lot of convenience to it. Things like how to load and unload pellets so you can use different colors, for example, are things that he has incorporated into his design. There is a little plate that you can take out to unload pellets that are already in there so you can reuse them. And there's even a way of clearing the barrel, as it were, which he shows you in the same part of this video. It's just all very nice modular designed 3D prints, which is always satisfying, I think, when people use very nicely designed 3D prints in order to make 3D printing itself better. And of course, as the title of the video mentions, this same design works with anything that is pelletized. So you can print with sugar, you can print with chocolate. All you need to do is, of course, is make some changes as to the heat and the speed with which you printed it, things that I know very little about. One other thing that I thought might be worth mentioning in my roundup is that this will work with whatever firmware that you already use on your 3D printer. You don't need to change that firmware. He is using Marlin on his, although of course there are other kinds of firmware. So it's hardware compatible, it is firmware compatible, and apart from a couple of metal parts, which I'm assuming he's going to be selling as some part of kit, some kind of a kit, it is all something that you can manufacture at home using a 3D printer already, or of course send off for those 3D printed parts as well. And there's a bunch of wonderful things in here. Oh yeah, this is the part of the video where he's mentioning that the screw that he uses was specifically designed to be wider so that it can accommodate larger pellets. Just lots of nice little things like that. I will leave a link to this video in the description as always, and if you are into 3D printing in any way, please do head to his website. The link is in the description of his video, and fill out the questionnaire. I am very excited about this project. I'm looking forward to seeing where it goes next, and it is definitely something that's going to get me personally back into 3D printing after a bit of a break. Now, this project is still ongoing, and as I mentioned, there's going to be a link in the description to his video, and you should definitely fill out his survey so he can make final tweaks to the design before releasing it. One of the big questions here, though, is why does this not already exist? The fact that someone could spend 2 years putting together this design is, don't get me wrong, it's an incredible achievement. But if one person could do this in 2 years, surely it would take one company a very small amount of time to put that together. But one has to wonder what the reasons a company have to actually do that. Do they think that there isn't the want for that? There's no demand for that? Or is it more a case of these companies already sell one kind of printer that works on spooled plastic? And if they also produce that spooled plastic, they have a financial incentive to keep producing it that way. Either way round, it doesn't really matter, because once Greenboy 3D's design is released, I'm almost certain that everybody will jump on it very quickly, and his resilience will be rewarded, and it will be a bit of a loss to the 3D printer companies in general for not having jumped on that earlier. But either way round, please do fill out Greenboy 3D's survey. I'm so happy that not one but two of the big breakthrough projects I'm talking about on this week's show have just been members of the Maker community, hackers who have seen something, thought I can do that better or differently, and just put their mind to it. It's exactly the thing that got me into this in the first place, and it's one of the reasons why I'm so happy to put a show out, despite the fact that I have a camera on a tree stump here and I'm standing in the middle of a forest, hoping nobody comes by and sees me talking to myself. I have an attic for a reason. Now we're going to move on to our feature on AI on single board computers that Robin has put together, a fantastic video and blog covering 7 great options for doing AI on single board computers, which is something I still find wild. AI is something that in my mind is still lofty and requires a mainframe in a lab to do, and the research and the differences and the changes that have happened in the last 10 years are mind-blowing to me. The fact that we can do things like tiny ML on microcontrollers is incredible, but single board computers have the advantage of having a full system, Linux or Windows, and being treated like a computer, but of course having a much smaller form factor and different I/O properties, things like GPIO pins and different ways of working with them. Robin is a perfect person to talk about this because he is an engineer that has experience in the field, but also someone that has a very good and concise way of talking about all of these things. So as always, I'm not going to try and parrot everything that he says in his video. There'll be a link to the blog and the video in the description, but in brief, here are 7 great choices for a single board computer for doing machine learning and edge AI. Now, this blog and video are from Robin Mitchell, who you know from the Electromaker Educator videos and also from our Product of the Week videos, so you know that he will give you a full run-through in both video and written form of all of the parts in this. So I will kind of go over it in a slightly faster way, maybe contributing a bit if I have hands-on experience. But as always, I would highly recommend heading to the link, which you'll find in the description of this video, to the blog article, and then you can choose whether you would like to simply read it or watch Robin's video. This is also published on our YouTube channel. You may have got a notification for it if you have notifications enabled on this channel. And as the article mentioned, AI has come on in leaps and bounds on single-board computers in recent years. It is a little bit crazy to think that the early days of AI were inaccessible to normal people, no matter how good their home computer was, and now it's working on everything from single-board computers to microcontrollers. Anyway, the very first board in the list is the Odoo Bolt. And this is a little bit of an older single-board computer, but it is still very much relevant and still very powerful. The V3 and V8 are 2 separate versions of the same board. They have different CPUs and different specs based on the version number, but they're essentially the same form factor. And you get something which is a single-board computer, but almost looks a little bit like the motherboard of a desktop computer, and it does pack quite a punch as well. And as Robin mentions in his write-up, one of the things about it that makes it very desirable is that it is extremely compatible. You can run Windows or Linux on it, and there are very few gotchas or hiccups. It is very well supported. You'll also notice that there are pros and cons for each one here as well. Just I thought I would point that out because I know pros and cons is something that some people quite like in order to kind of help themselves make a decision. Again, I will not go through all of them in my video here. You can definitely come and read this or watch Robin's video in order to get that part of it. And as you see here, there are the pros and cons of this board, and indeed every board on this list, if that's the kind of thing that you're interested in reading. Now, the full specs of the V3 and the V8 are listed in the datasheets just underneath, but they're also listed in brief on the article side as well. Moving on to the Latte Panda series. Now, I have played with the Latte Panda Delta and I was very impressed with it. The Latte Panda Sigma is apparently even more impressive. I haven't had hands-on experience with that as of yet, but I haven't used either of them for AI. However, as they are both x86 single-board computers, much like the Odoo, they find themselves in that similar position where it's very easy to find compatible libraries to work with, whether you're working with Windows or Linux. The Latte Panda also has a Arduino-based microcontroller built in, or what I should say is it has a microcontroller that is compatible with the Arduino IDE built into the board itself, which makes it the perfect thing for input and output. Whether you want to use kind of AI-based smart sensing, you could have GPIO pins for sensors and then have a camera plugged into one of the USB ports, for example, or you could use this as the brains of a robot. There's a lot of different ways you could work with it. And as it mentions here, there are 3. There's the Latte Panda Alpha and the Latte Panda Delta. There is also the Sigma, which is the more recent one, which is an absurdly powerful powerful single board computer. Yes, it costs a little bit more than your average Raspberry Pi alike, but you get a lot more grunt for your money. And again, the video and blog goes into pros and cons and a little bit more of the specs. But moving on to the BeagleBone AI. Now, I always have a real soft spot for anything that BeagleBone/BeagleBoard put out. I have called them BeagleBone for so long, I accidentally call them that every time. But of course, the company is BeagleBoard. But the BeagleBone AI is their AI-specific board. And what is pictured here is the BeagleBone AI 64. And this is a 64-bit AI-specific board. And the beauty of it is that it will work the same way as any other BeagleBoard that you've ever had before. One of the things I really like about everything that they put out is that if you have a BeagleBoard and you plug it into the USB port of your computer, then you open the browser and you can just start coding it straight away. It has an IDE built into the browser that works over USB. And of course, you can set up your own development environment. You can do a million and one things with it, but for pure accessibility and getting started with them, I find BeagleBoard wonderful for that exact reason. However, this is an AI-specific board, and as Robin mentions, there are AI-specific features on board. Like it has its own AI acceleration. It is designed very much to fit into an industry-focused an industry-focused development group. We'll go with. I'm basically in a cupboard at my relative's house, and it turns out my brain doesn't work very well when I'm in a cupboard. Equally suited for personal or industrial use might be a better way to say what I just tried to say a moment ago, and you can find out some pros and cons and the specs in the article linked in the description. Now, unsurprisingly, the NVIDIA Jetson series is something that gets a mention. Here, Robin focuses on the Orin series, but it is worth mentioning that everything from the Orin to the Xavier, right down to the Jetson Nano, are all wonderful boards to learn the basics of AI. And that is because NVIDIA have really paired their hardware and software libraries together in a way that has kept up with one another since the very start. I had no experience in AI whatsoever when I first got a Jetson Nano, and just sort of going through all of their examples and kind of getting my head around how it all worked was something that I found remarkably easy for someone that had little to no knowledge about that subject at the time. Now, I still have little to no knowledge of that subject now, given that it's such a broad subject matter, but yeah, the NVIDIA hardware-software divide is something that I find very interesting. Their Jetpack SDK, I think it's been renamed in recent years, makes it very easy to get examples up and running. And I have seen examples at trade shows of the Orin doing really quite special things. Multiple person camera recognition, not just recognizing multiple people in a scene, but multiple attributes of those people, all of these things running in parallel. NVIDIA, unsurprisingly, using parallel GPU processing as their real grunt tool. That's what they use to do all of their processing, that's what they use to do all of their AI, and it is unsurprising given that NVIDIA are also the video card company. And there are in fact three variations of the Orin board as well, the Nano, the NX and the AGX. As to whether they are designed to replace the Jetson Nano and the Xavier completely, it remains to be seen. That's not something that I was aware of, and if that is the case, then I'm perhaps a little behind the times. Who'd have thought it? But yes, the NVIDIA embedded range has been going hard with AI since the very get-go, and I still think from my perspective, if I was to try and build an AI project from the ground up using embedded hardware that wasn't using microcontrollers, I would probably go with an NVIDIA board. NVIDIA aren't paying me to say that. This is just the ideas of an idiot in an attic, or in this case, in a cupboard. Now moving on to the UpSquared Pro 7000 series. UpSquared are the name on this list that I have the least experience with, in that I have had no hands-on experience with an UpSquared single-board computer. What I have had is experience of Up becoming a name that is much better known in recent years. Back when I used to write news about single-board computer releases and all that kind of stuff, it seemed like there was a time when consistently Up were coming out with really solid single-board computers that were not seeing so much hobby use because they costed slightly more than hobby boards. We're seeing a lot of commercial and industrial use because of their fantastic spec, fantastic support, and just the fact that they had everything that was needed in that space. So I have no reason to doubt that Up haven't thought about all of this and have tried to bring this to their kind of AI industrial version of their products. But beyond that, there's not really much more that I can say, which is why, once again, Robin has you covered. The video will go into any reasons why you might want to get this, including various pros and cons for it. As it says, I think this is the one that specifically is designed to work with Intel's. Yeah, look, its compatibility with Intel's Edge Insights for autonomous mobile robotics exemplifies its suitability for high-stakes environments. And this is the language that is used in this sphere. If you are making an industrial robot that is going to be working alongside humans or alongside things that cost a lot of money to replace, you need something that you can trust. And presumably that is exactly what Robin is getting at when he writes this. Because ultimately it doesn't matter how cheap your single-board computer is or how easy it is to get the AI model up and off the ground. If that is not something that you can trust with your business or trust around your workers, then it is near useless. And presumably that is exactly what the Up Squared AI board is specializing for. Presumably that is what Up is looking to specialize in with their board. But I'm using a lot of maybes and presumablys here because I'm not going to tell you something that I do not know. But this is exactly why we have someone like Robin in-house who can. Now, I don't think anyone is surprised to see the Raspberry Pi 5 on this list. I personally find the Raspberry Pi 5 a bigger jump from the Raspberry Pi 4 to the 5 than from the 3 to the 4. And I know some people will get very annoyed about that, but the Raspberry Pi 5 is phenomenally fast, and it has the PCIe extension on it natively, which allows you to attach various other things to it, including AI acceleration. So the single-board computer on its own, despite its incredible speed increases, isn't really suited for AI tasks. That isn't to say that you can't use it to learn. I, in fact, did some of my very first testing with TensorFlow was on a Raspberry Pi with no acceleration whatsoever. But the difference when I then put in one of those USB Coral accelerators was phenomenal. This is going to be much better without any kind of acceleration, of course, but by PCIe extension and the fact that there are already hats available for doing AI with the Raspberry Pi 5, I imagine it is something that's going to see wider use because of its availability, because of how well it is known, and because it is something that is highly supported. You are likely to find code examples of the Raspberry Pi 5 being used for AI pretty much as soon as that is something that is possible, and this is the argument that is always put forward for Raspberry Pi. They make fantastic hardware, but they have a huge community of people who are working to get everything possible working on that hardware. Finally, we have the Arduino Portenta X8, one of the Arduino Pro line and the highest level, as it were, Portenta, the highest spec Portenta by far. But it is somewhat unique because whereas the C33 and the H7 are both microcontroller-based solutions that just step up the power, the X8 is a dual solution. It has a microcontroller on it, a very powerful STM32 chip, but it also has an ARM-based processor for running Linux on it, and you can run Linux and a real-time operating system side by side on it. And there are various pro libraries that are designed specifically to make that abstraction a little bit easier, or I should probably say to abstract that to make it easier for you. However, there is, as it says here, a modular approach to AI. The real strength of the Portenta is just a huge amount of things that you can attach it to. They have, and I think there's an image of it in this blog, this board that essentially is like a motherboard for attaching the CPU of the Portenta X8, and you cannot see the air quotes I am doing without a camera, but that's what I'm doing, to turn this into a really extendable board with every kind of peripheral that you might imagine and anything that you might want on it. And there's a huge amount of things being added to the Portenta ecosystem all the time because it is something that they are really pushing for use in the industry. But what with it being Arduino, it is relatively easy to get up and running from a hobby perspective as well. But ultimately, as the title says, a modular approach is the real key here. The Portenta X8 by itself is an incredibly powerful processing unit. How you want to expand that is entirely up to you, but it does mean that while you might be spending an initial outlay on the quality of the original parts, you're not spending any money on bits that you do not need, which in the long run might save you money depending on the project that you are working on. Again, modular AI is something that is completely new to me. I'd love to see an example project of AI with a Portenta X8, and perhaps if I find a nice one, that's something we can go through together on a future Electromaker show. That was our podcast this week. Thank you so much for joining me. I forgot to mention at the start, but I was recording this show not in the usual Attic of Dreams space and on a different microphone to usual, so there may be some slight differences in sound quality. I've done my best to, from memory, put some parity between the sound you get in the studio and the sound you get with this field recording microphone. It is a very good microphone, but it is a different microphone to the normal one. So yes, do let me know if there was any appreciable difference, because it's always worth noting these things down as a sound sound design and all that kind of stuff is what I really love underneath it all. But other than that, I hope you did enjoy the show. As always, quick reminder to head to electromaker.io/shop if you want to pick up whatever you need for your next project or for your business. That would help us out greatly. And I will speak to you very soon. My plan is to try and get a podcast out next week at Embedded World, regardless of whether we get a show out. We will obviously be doing a lot of interviews and things like that. At very least, I'll try and edit together some of the audio from some of the interviews that we do and put that out as a podcast with a few in-betweens here and there too, as I think that would also potentially be quite interesting. But we will just see how we go. Worst comes to worst, I will speak to you in 2 weeks with a full rundown of everything we saw on the floor at the Embedded World Conference. But until then, I hope you have a safe, fun and creative week, and I'll chat to you soon.